Today's lab is the determination of the molar mass of a solid acid and standardization of a base. The purpose of this lab is to be able to standardize a solution of sodium hydroxide and also to determine the molar mass of a solid acid. The first step in this lab is to prepare the burette for use. The burette needs to be rinsed thoroughly with deionized water. After it is rinsed thoroughly with water, there needs to be 5 milliliters of NaOH added to it, at which point the burette with the solution will be gently rolled and the entire inside will be coated with NaOH. The burette should then be returned to the burette clamp. The next step is to standardize the NaOH. Weigh approximately 0.4 grams of KHP into a weighing boat using the analytical balance for exact precision. Then the KHP needs to be dissolved into about 75 milliliters of deionized water in a 250 milliliter Erlenmeyer flask. 3 drops of phenolphthalein should then be added. The initial volume should be recorded at this point. The titration should then occur. Then the final volume will finally be recorded of NaOH in the burette. This needs to be repeated 2 more times, and then the flask can be rinsed with a small amount of acetone to dry it. The final step of this lab is to determine the molar mass of the unknown solid acid. You can weigh approximately 0.2 grams of your unknown acid into a weighing boat, and then you can dissolve this in 75 milliliters of deionized water, again, just like you did with the KHP. 3 drops of phenolphthalein will be added once again, and the initial volume of the NaOH will be recorded. The endpoint will be reached through titration, and then finally, the final volume of the NaOH will be reached and recorded in the burette. You need to repeat this 2 more times, and then finally rinse the flask with a small amount of acetone to dry it.
Here is the data for the standardization of NaOH. Here is the data for determining the molar mass of a solid acid. To manipulate the data, first calculate the moles of NaOH necessary to react with the KHP. Convert the KHP to moles and use a mole-to-mole ratio using OH- to find the moles of NaOH. Repeat for each trial. Then calculate the volume in liters of NaOH used to titrate the KHP. Subtract the final volume of the NaOH from the initial volume of the NaOH. Then convert the answer to liters. Repeat for each trial. Calculate the molarity of the standardized NaOH. Use the calculated moles from Part 1 and divide by the liters of NaOH calculated in Part 2. Repeat for each trial. Calculate the average concentration of NaOH. Add all of the calculated molarities from Part 3 together and divide by 3. Then calculate the total volume of NaOH added to the unknown acid. Subtract the final volume of NaOH from the initial volume of NaOH and convert to liters. Repeat for each trial. Calculate the moles of acid present to react with the amount of standardized NaOH used in each of the trials. Convert liters of NaOH to moles using the average concentration calculated in Part 4 and use a mole-to-mole ratio to find the moles of unknown acid. Repeat for each trial. Calculate the molar mass of the acid. Divide the mass of the acid used by the moles calculated in Part 6. Repeat for each trial. Finally, calculate the average molar mass of the acid. Add the 3 molar masses calculated in Part 7 together and divide by 3. Conclusion. Using the data that was collected from the first part of the experiment, the concentration of the standardized NaOH could be calculated. Using this calculation and the data from the second part of the experiment, the molar mass of the unknown acid could be found, completing both of the objectives of the lab. Their molar mass was calculated to be 126.8 grams per milliliter. There are many possible errors that can occur during this experiment. One error is under-titrating the solution. If the solution does not turn a steady light pink color, it has not reached the equivalence point and is under-titrated. This will cause the total volume of NaOH used to be less than it should be. This will cause the calculated molarity of the standardized NaOH to be greater than it should be. This will then cause the moles of unknown acid present to be greater than it is and the calculated molar mass of the unknown acid to be less than it is. The opposite of this error is over-titrating the solution. This is when the solution turns a bright pink color and has passed the equivalence point. More NaOH will be used, causing the calculated molarity of the standardized NaOH to be less than it is. The moles of unknown acid present would be less than it should be, and the calculated molar mass of the unknown acid to be greater than it is. Another error is forgetting to put the phenolphthalein into the solution before beginning the titration. If an extremely large volume of NaOH is mixed with the solution and there is still no color change, there may be no phenolphthalein in the solution. If it is then added and the solution immediately turns a bright pink color, the solution is over-titrated, causing the same effects to the results as over-titrating the solution. An error that can occur before beginning the titration is not thoroughly rinsing the burette with NaOH. If the NaOH that will be used for the titration is added when there is still water in the burette, the NaOH solution will be diluted. This will require more NaOH to be added to the solution to reach the equivalence point, affecting the results the same way as over-titrating the solution.
Theory. Titration is often used to standardize a solution. A concentration can be determined against a known reference using it. Knowing the mass of the KHP, for example, allows one to determine the moles of NaOH to reach an equivalence point. The volume can thus be determined, but the molarity cannot be. Determining the molarity requires the ability to use stoichiometry, as demonstrated in the calculations. Grams of KHP must be converted to moles of sodium hydroxide. Students must also be able to calculate molarity from these calculations. Moles are put over liters of solution. Being able to use stoich to get moles and moles in volume to find molarity is very important. These are primary skills required in calculations. Understanding the significance is very important in understanding acids, bases, and standardization. This skill is used in lab activities very frequently. Using prior skills such as stoich to problem solve is what enables us to use and understand practical applications.